Hi, welcome to the Engineering Room. This is an additional series of longer form conversational style chats with influential people from software development. And it's meant as a kind of complement to the more regular channel content. This series is sponsored by Equal Experts. Equal Experts is a product software development consultancy with a network of over 1,000 experienced technology consultants globally. They increase the pace of innovation by using modern software engineering practices that embrace continuous delivery, security, and operability, and many of the other ideas that we talk about on this channel. So please do check out their links in the description below. My guest today is a friend who I've met on the international conference circuit. We've spent many times having a beer together and arguing about software development in different parts of the world. Michael Feathers is the chief architect of Globant, the director of R7K Research and Conveyance, and an authority on working with and modernizing legacy code. His book, Working Effectively with Legacy Code, is cited extensively by leaders in the industry. He was a pioneer of the Agile movement and has helped hundreds of organizations from Fortune 100 companies to startups design better software, revitalize their code, and change processes. Working effectively with legacy code is so well known and such a wonderful book. My brother-in-law was telling me before I started on recording this today, how excited he was that I was talking to Michael, since working with effectively with legacy code has been his Bible for the last 6 years, building systems. He's on his second copy because he wore out the first one. So Michael, welcome to the Engineering Room.
Well, thank you.
And thank you for agreeing to have a chat today.
Excellent. Yeah, I mean, I look forward to this. It'll be fun.
Yeah, so I think of you as you know, an XP practitioner, an expert on architecture and design, and close to the technicalities of great design and thoughtful, insightful design thinking. So, how would you characterize good design in code, do you think?
Oh, wow. Yeah. Characterizing good design in code. It's kind of funny because, I guess every year that you ask me, I'll have a different answer because, it's one of those things that's almost like a background thought, in all of my life. Yeah, good design. I guess the standard way of going and looking at this is basically easy to maintain, easy to understand, right? And I think I've kind of arrived at quite a bit more recently is just the notion that so much of what makes those things possible is really kind of like an artifact of the way our minds work, right? It's kind of like there's something called Miller's Law, which sometimes people refer to as the 7 ± 2 rule. Like how many things can you hold in your working memory when you're trying to go and understand something? And it's kind of like, if you want a design principle, that's a very basic one. It's kind of like we want to basically have things scoped to human size, to be able to go and actually work with them, to be able to go and find them, discover them inside large existing systems, make the change we need with minimal impact on other things. And, if we can do those things, then we're in a good state where you have a system that basically allows us to work well. So yeah, that's a long-winded answer. I'm sorry for that, but it's,
No.
it's kind of like, that's the way I'm kind of seeing it right now, I guess.
Perfect. That aligns very, very profoundly with the way that I think about that as well. So in my book that we were talking about before this, the engineering book, I talk about optimizing for two things: optimizing for learning and optimizing for managing complexity. And to my mind, what you just described is exactly the second one. We need to manage complexity, and we need to manage complexity to the capacity that we as human beings have to understand things.
Mm-hmm. Yeah, definitely. What was the other one you mentioned? I just missed the little piece.
Optimizing for learning. So I talk about I talk about some ideas like iteration, feedback, experimentation, those sorts of things to optimize for learning, and things like modularity, cohesion, separation of concerns as techniques for managing complexity. Organizing things around that. But I think it's interesting. One of the things that I wrote about in my book, this is not me trying to sell my book, but one of the things that I wrote about in my book was the idea of automated testing, testability, test-driven development as a way of enhancing the quality of our designs. And during my refreshing my mind about the things that you talk about, I found an old conference talk that you on YouTube that you recorded some years ago, which we'll put a link in the description, where you were talking exactly on that topic. So I'm going to quote you at you. So every time you encounter a testability problem, there's an underlying design problem. Could you just explain that idea a little bit more?
Yeah, sure. Yeah, it's a weird thing. I just, if you don't mind me, like, backing into it a little bit from where,
No.
it came from, at least in my recognition of it. In the very early days of like people trying to apply unit testing in systems, one of the things that came up all the time is like, oh, I've got a class, I want to write a test for a method on the class, but guess what? The method is private. What do I do, right? And it's kind of weird with that because an entire segment of the industry went on creating special add-ins to unit testing frameworks to go and say, okay, let's bypass the protection and let's do this, this, and this. And, it's kind of like, and, I mean, there were a lot of people who saw no problem with that. And to me, that just smelled funny, right? And then talking to people in the nascent XP community and stuff like that, I kind of like, people say, well, if you have a private method you want to test, then you're, chances are it's like maybe that's part of an abstraction that's begging to be pulled out of the bigger thing you have, and you can break it down into smaller pieces. So the thing that was, one thing to get about me is I basically am driven completely by curiosity, right? So I couldn't figure out why that was necessarily true or why it worked so often. And then I started thinking about it an awful lot and started making a list of all the different things that are like that. Like you have a pain when you're testing something, and it turns out there's a design problem. And then if you fix the design problem, testability becomes easy. And, there's all sorts of things like that. So there's the thing of, private methods. Gosh, what are some of the other things too? Like you make a change, you have to go and change 15 tests in order to go and actually sort of change, the thing that you want to go and deal with. That can be a design problem as well. There's all these little things that are like that. And what I finally arrived at was seeing a conference paper from, I forget what the conference was. It was a spinoff of the UPSLA conference. And someone was making the case, they mentioned a little bit earlier, that essentially good design is really an artifact of the way our minds work in a way. And, so he was going and making this case and going through and I said, aha, I get it. Essentially what it comes down to is that if you are, when you are trying to write tests for something, you're trying to write a program to understand the program. I mean, that's one way of framing what we do.
Yeah.
And if it's hard to write a program to understand the program, it's probably hard to understand the program, right?
Yeah.
So it's that kind of thing of going and recognizing that. I mean, another one to go and add in here as well is like sometimes you're using a framework and it's hard to write code hard to test code that uses the framework because you can't mock things out very easily. It's like, well, design problem is like, not very good separation of concerns. You should minimize the connection between the framework and the thing that you have as domain code and stuff like that. And so in the talk, I give a whole list of maybe I think 10 or so, different places where this seems to apply and use it to drive that home. So it was a great talk, and I confess I didn't learn anything from it because it so strongly reinforced my prejudices and my own prejudices. But it was a fantastic talk, and I liked the way that you broke down the individual cases. But I think that idea of kind of writing a program to evaluate the program that you're writing is an interesting one because it makes us, one of the things that I love about test-driven development quite so much is that it puts me in the position of a consumer of my own code, because I'm going to write the test, I'm going to be consuming my code, and then going to say this is horrible to use, so I'm going to change it so it's nice to use to make it easy for me to write the test. And there's a pressure on me to, I'd be rather foolish if I'm not going to expend some effort to make it easy for me to write my own tests, and therefore easier to use my own code. Totally. And I think when you're writing new code and doing TDD, that's a great thing with it, to go and sort of like, see that connection. One thing I quite often deal with people that have large existing code bases and trying to get tests in place, for them, right? And the thing about this that's kind of funny is that people can easily walk away with the perception that testing is just hard, because they're trying to test code that was never designed to be tested. And it's kind of like I said, no, once you sort of like see that the pain you're experiencing when you're testing has a real root to it, then basically it's almost like having, your tests are almost like a mentor in a way. It's kind of like
Yeah.
going in and teaching you about good design just in the process of encountering pain and thinking about what you could have done alternatively when you were designing the system or somebody else was.
Yeah,
Yeah.
I think I say the same thing, but in different words. One of the ways that I talk about this is that it just gives us almost instant feedback on the quality of our design. And that's probably the thing that I value most in test-driven development, more than almost anything else, is that I don't really. If you're a talented software designer and an experienced software developer, you've probably got some thoughts and ideas and opinions on what, how to make a good design. But I don't think anything else gives you quite the same level of fast, instant, visceral feedback that writing a test and finding it hard to write your test.
Yeah, it's weird because I've tried to dig back and figure out, well, hey, where did all this stuff come from? And of course, like, Kent Beck and Ward Cunningham and very, very early pioneers of XP and stuff like that. And I don't recall whether one of them said this or I just kind of like said, oh, put two and two together. But, their early work was like in Smalltalk, right? And essentially it's not quite a REPL, but you have something called the transcript window and you can just try things out, right?
Yeah.
And I thought, in a way, this thing of going in, doing unit testing is a way of going in sort of like building a REPL for what are quite often statically typed languages. And you're able to try things out in this test harness. Yeah. And then, of course, the great thing is that we have durability. It's kind of like those things can live forever, too. But yeah, the ability to play a bit in a way where it's easy to fail and not hurt things is just like a great affordance that testing gives us, too.
Yeah. So I think that both of us would probably think of ourselves as kind of devoted TDD practitioners. We're both pretty committed to that being the best way of doing things, and therefore, presumably, without me putting words in your mouth, you, like I, wish that it was more widely adopted. Is this one of the barriers? Is this one of the barriers? Do you think that the fact that this is principally so? I think the implication of what we're saying is that this is principally about the quality of design. This is good designers maybe find testing easier, and poorer designers find it harder. Maybe that's the barrier to entry, because learning good design is difficult.
Yeah, I wonder, because I think that I feel like there's two other things a bit as well. One is what I call the one more thing problem, which is kind of like, I think it's easy for many people who've been in the industry for a long period of time to think, wow, I can just introduce this practice, and if people do this practice, they're going to get an amazing benefit. But the thing is, for the average developer in the trenches, they're thinking about all the things that they need to go and do, and you're just giving them one more thing, right?
Yeah.
That one more thing really has to pay for itself, and they have to be able to go and sort of see how it pays for itself in order to go and add that to the list of all the work that they need to do that they're really being evaluated on. And I think we're constantly running against that in the space of software development. So I think there's that aspect of it. And the other thing too, I think, is that testing requires you to think a bit more abstractly about your code, or at least you're kind of like, instead of saying, I'm going to think about the problem and solve the problem, you have to think first about how to articulate a test for the problem. And then, so you're moving one level back, right? And I think for some people, there's maybe an impatience, or maybe not really seeing the connection of, okay, well, if I write the test, the code is going to come and it's going to be okay. But it feels like, what's the old thing people used to go and make ships in bottles, using the tweezer thing, like that. At least that's the metaphor. It's like, okay, I'm doing things at a distance in order to go and create the thing that I want. I think that's counterintuitive for people sometimes. I could be wrong, but it's a guess.
So do you think it matters? Do you think it matters? Do you think it's something that? So I pushed quite hard for test-driven development. I recognize all that you say, but I do try and push quite hard to encourage it and promote it. Do you think that's a sensible effort? I guess I'm trying to ask a leading question, and the real question that I'm trying to get to is, I'm fairly hardline on test-driven development. I think that software is almost never as high quality in its absence. And that's a pretty hard line to take. But that means that it's important, therefore, to try and get people over that bump of there being one more thing to learn and this separation. But that's an effort that's worthwhile.
Yeah, I totally agree that it's worthwhile. And whenever I, it's funny you mentioned my book a little bit earlier, but as soon as I think of my book as scare tactics for test-driven development, it's kind of like once you discover how hard it is to test existing code, you're kind of like, well, I'm going to basically write tests from the very beginning so I don't encounter this problem, right?
Yeah.
So yeah, I do feel very strongly about it still. I think that the rough part is basically there's sometimes some zeal around it, which can be beneficial at times, but also can be kind of off-putting for people. The way I always kind of look at it with developers I'm working with is, give this a shot, see what it does for you. And I concentrate on their experience of pain.
Yes.
And sort of point out, it's like, this is a way of going and avoiding that problem of kind of like, the story I always tell is like early in my career, some friends would come by and say, hey, Mike, do you want to get some coffee? At like about 1 o'clock or 2 o'clock in the afternoon, I'd say, no, I'm juggling eggs because I'd torn up my code so much. And I wasn't sure I'd be able to go and sort of get it back in working state before leaving at the end of the day. And after applying TDD, I just realized I could walk away at any moment and just press the button when I get back and see whether things are working or not. And that's a priceless feeling to be able to go and have as a developer, to know that things are still working.
Yeah, I got into the habit when I was doing this on a daily basis. I don't write code every single day anymore, but when I was writing code regularly for real outcomes, I got into the habit of leaving on my local computer just a failing test, so I could come back, run the test, see it fail, and I could carry on from there.
Yeah, it's a bookmark.
Just leave, continue my train of thought from the previous day.
Yeah, it's all good.
So I try hard not to be a zealot about things. I try to think carefully about the reasons why I want to do things, and as you say, you need to put it in context and help people to the answer rather than wag fingers at them and tell them they're naughty if they don't do it. But it is one of those things. Yeah, it is one of those things that's kind of hard. It's like teaching your children to brush their teeth so that their teeth don't fall out before they grow up.
Yeah, and I think and the rough thing, it seems, also it's like in a team situation, you get one person who's really excited, and then they become kind of like, they're proselytizing throughout the team, and everybody's like, oh, shut up. It's kind of like, I know this is working for you, but it's like, whatever, I don't want to hear about TDD today, right? Yeah. So it's that thing of like, sort of like, is it a British term, a keener, a person who's very keen on things or something? Or like, I don't know. Anyway, but like,
might be Australian. I don't know.
Yeah. But it's kind of like sometimes people have to be a little bit subtle.
Yeah. Absolutely. So one of the things that intrigued me, and it's a long time since I read your book, so it might be that you wrote about this in your book. But one of the things that I think about in terms of the difficult parts of doing test-driven development are what I call testing of the edge, at the edges. So the points where you're performing I/O of some kind, or you're kind of reaching out, and you need to come back into the system in some way. And I wondered whether one of the problems that makes it hard applying this kind of stuff in legacy code settings is that there are so many edges very often in those sorts of systems.
Yeah, it's like there's no price to going and just introducing them, because like, hey, you have an API you can use, I'll just use it right here, that kind of thing, right?
Yeah.
So I think the interesting thing with testing is that, to me, it seems like it introduces a constraint which allows you to go and sort of like get some separation between the pure logic of your system and then basically the things which are IO related or external world related and stuff. And we've known for ages, like Alistair Coburn's notion of hexagonal architecture, for instance, that you want to have like this core, and then basically you have the periphery, which is kind of like contact with the world. But this is like a constraint that kind of helps people arrive there when they're doing TDD. otherwise, yeah, it's rough. It's kind of like you have to do a lot of mocking or extracting of logic and pointing to different places to make things testable in many cases, which is awful, you know.
Yeah.
So
So what are your kind of techniques to alleviate that problem?
yeah, well, I think it's kind of funny because you know, I wrote the book ages ago. So like this thing of synthesizing, you know, this, I think one thing I always look for now is like, is the thing I'm working on a glue system, or is it more like a computational system in a way, right?
Yeah.
There's some code I used as an exercise years ago, and I still use it at times. It's kind of like a code for a mail server in Java, right? So essentially you send it mail and it goes and sends it off to a bunch of, you know, recipients. And when you look at the system, everything is a call to the Java Mail API, right? And except for maybe 2 or 3 things which are computational. And I think from my point of view, you've got a choice there. Like you're either going to go and, you know, test the full thing end to end by really sending mail and having it send mail back to you,
Yeah.
or you're going to find computational bits and try to go and isolate those and get test coverage around those in order to go and do the things you need to do. So you have to kind of know which kind of a system you're in. You know, are you one which is really mainly glue code between APIs, or is it really a computational thing? And if it's a computational thing, then I think unit testing is really, you know, a good answer in that space to go and isolate the computational things and do the work that you need to do. There's that. I think the other thing I come back to, I don't know whether you get to it in your book. I've got your book also. I haven't read fully at this point, but the notion that you don't have to test everything right away. You know, essentially, it's like test as you need to change things.
Yeah.
And you know, the way that things happen in systems, you know, it's like some areas you'll never touch again, and other areas you're going to touch over and over again. And you know, the latter tests, and you know, you don't have to be upset that you only have like 52% coverage in your system. It may be that way in 2 years also. It might be more up to 60.
Yeah.
But number isn't the goal, you know, it's just getting coverage for what you need to do. Yeah.
Yeah. And as you say, you know, doing that tactically in the parts of the system that matter to you at the time when you're working, you make the bits where you're working habitable.
Yeah, totally habitable. I love that word for that.
Yeah. Another of those quotes that I picked up in my research on I'm going to throw back at you is that object orientation, when it's done right, looks a lot like functional programming. There's a contentious thing to say these days.
It is, yeah, but I think it's and I don't mean it quite literally, but really more like in its effect in a way.
Yeah.
No pun intended, because you know there's a side effect issue with functional programming and stuff like that. But, you know, it's when you look at like a system that you're trying to go and get tests around and object orientation, for instance, one of the basic maneuvers is essentially like dependency injection, right? Or, you know, I think the very simple way of looking at this, even if you're not using a dependency injection framework, is parameterize the constructor, just passing all the dependencies through the constructor, right?
Yeah.
And typically these dependencies are things that do IO or interact with other parts of the system, stuff like that. So you can look at, you know, the entire object as being a thing which is parameterized, and basically it should be pure computation in the sense that it goes and grabs things from the, you know, the inputs, maybe writes things to the input objects and stuff like that. But it's kind of like, it's very clear what the inputs and outputs are to that piece. And it's that aspect of functional programming that I see mirrored in good OO in a way. It's like that you get a degree of locality where you know what's going in and you know what's coming out because it's explicit in interfaces. And, you know, functions are that same thing to an extreme. But good OO tends to align in that direction, at least in my opinion.
Yeah, and I think that the synergy of OO design and test-driven development tends to push you in that the direction of that kind of design as well. I vaguely remember us having a conversation a long time ago about the kind of surface area of the system and the testability, you know, that's imposed on you by testability. One of the criticisms that I see from time to time is, you know, is that the test-driven development can have a put impact to make your designs worse by decomposing the system into lots of tiny pieces. And I remember you saying at the time and reassuring me in my opinion, which was, actually, that's just the surface area of the problem that you're seeing there, that the test-driven development kind of shines a light on, or words to that effect. It seems this seems similar to me in that light. It tends to push you in the way of doing OO better as well.
Yeah, no, definitely. It's an interesting thing with this too, because I think one of the things I've really come back to an awful lot recently, I was really impressed by a talk I saw by Ian Cooper. Do you know him at all?
Yeah.
Yeah. And it's
I've seen some of his talks. I don't know him personally.
Yeah. But it's like he was going and he was talking about that tension between basically like you're testing a whole chunk of a system, which is more integration-y, versus like every single class gets its tests and stuff like that. And it made me think that a lot of times when I'm doing TDD, quite often I start with something and I write tests against it, and it kind of ends up becoming a facade because I start extracting pieces out, which is, it's a bit different from what like Steve Freeman and Nat Price would do in growing object-oriented systems using tests. Because I don't know, but I think I lean more in this direction now of kind of like you're growing out from a facade, and in a way. But I go back and forth. It's really kind of hard. I think we've had a debate within the industry for quite a while about, are you testing each piece individually and then knitting them together, or are you basically testing something that you're going to grow outward? I know in the legacy code situation, the latter tends to happen quite often. You'll find a God class and you're trying to make changes to it, and you write some tests against the facade of it. And then you're kind of like, well, gee, I've got enough coverage now to go and extract out pieces. And you do that, and then you still have this kind of hierarchical structure that way, but it's okay because it's understandable and you've got test coverage and you can march forward. Of course, I was a little bit rambly, but I think there's forces at play with that in a way. Are you making pieces or are you kind of like growing?
I think it goes back to what you were saying earlier about the limitations of the human mind. You don't always know the right way forward, and so you're exploring. You're in learning mode. You're discovering new things, and one of the ways of doing that is just jumping different levels of abstraction. So sometimes you want to jump up and get that kind of broader picture of how do these pieces hang together. Oh yeah, now I see it, and now I'm going to go down and I'm going to look at this detail. I'm going to test this little piece.
Yeah, definitely. There's, I think, like another related thought around that is been thinking about modularity an awful lot over the years. And when we get back to that thing about testing pain and it pointing to design problems, it made me think back to the thing that we've always had about like, how do we name the testing that we do? And it's like, it seemed like people would say, hey, unit test isn't really a good name for this. And let's call them programmer tests, or let's call them micro tests, or all these other things. And I felt like it might be an interesting thing to flip around and say, well, we could call them unit tests. And then people would say, what's the unit? And I'd say, well, it's the thing that you can test easy, in a way. It's like if you have a chunk that's this big and you can test it easy because it has minimal coupling to other pieces, then that's the unit that you tested. Doesn't matter if it's like 3 or 4 classes working together, but it ends up being this cohesive chunk that you can actually work with. If it gets to be 10 or 15 classes and you can't effectively test it because, like the distance between your inputs and outputs and what's really going on is so far that that's not understandable, probably not a good unit. So I think that thing of going and having tests basically help us see where the modularity currently exists in the system, and then how we can actually sort of fiddle with it to go and make it better is like
improve on it. And one of the driving principles for that I use often, and I know you talk about as well, I think maybe we use different terminology, but separation of concerns. Striving to make sure that each part of the code is doing one thing. And again, that idea of the testability of the system helps us to see those opportunities. I think that was an aspect of the way that I applied and thought about design anyway. But I worked for a few years alongside Martin Thompson, who I think as well. He's a good friend of mine, and Martin's a great programmer, but he has a laser focus on separation of concerns. Immediately, he spots the slightest hint that any piece of code is doing more than one thing. He's ripping it apart and he's just trying to figure out how to get that, you know, that thing out and somewhere else. And his code is just really nice to work on as a result, because each piece you can see exactly what it's doing. You know, it's all there in front of you, and it's clear and it's testable. But it's small, and it talks to, you know, it may talk to another piece somewhere, and that's clear and easy to understand. But then you've got to have that ability to kind of synthesize the picture a little bit, which I can kind of see the criticism of the surface area, but that it does make each piece easy to work on, and it does make each one easy to understand. And
what's wild is like when you have like really extreme separation of concerns like that, it's almost like every object becomes a lever in a way. Yeah, it's like you want to change how this operates, tweak this one lever, and it's really obvious that this is the lever because that's the place where it resides and it's doing nothing else, right?
Yeah,
and I think that's, you know, a powerful thing. I had a really weird experience early on. Like I remember trying to learn, and I looked at something called the hot draw framework that was kind of like, I believe it was Ken Auer and Kent Beck working on this. And I think Ralph Johnson was involved in one of the early design patterns guys. I remember looking at this code, I had nobody to explain it to me. And it was like all these little objects. I'm kind of like, how does this all fit together? I tried making CRC cards to go and look at how all this stuff was. And I remember reading someplace, I forget where it was. It's kind of like when you factor at a very fine grain in a system, it might be a little bit harder to find where you need to make the change. But once you find that place, it's easy. Yes. So you're trading off. There's a little bit of extra discovery cost sometimes for where something resides, but then it's kind of like the modularity gives you the affordance to be able to go and really tweak things the way you want to. And it's kind of interesting to write, but it's tough for developers quite often because they're kind of like, I can't understand everything. It's all over the place. And, you know, it's part of the learning curve, I think, you know. Yeah,
exactly. And I think that then comes into one of those unpopular topics, you know, architecture. You know, the architecture. I've started using a silly phrase to talk about architecture, my view of architecture, but I think of architecture rather like a tourist map of a system. That it kind of gives you a vague layout. It's not a precise map. You're not going to be able to measure distances on it, but you're able to find your way around, and you're able to navigate to certain parts of the system, and then you can see what it's doing. And I think it kind of works for me on the way that I tend to use architecture as sort of just a rough guide, so we can all agree, this change lives over there, and then you zoom in on the detail, and the code tells you the rest.
Yeah, no, I love it, and it's interesting. That's a great segue into something I've been kind of like working on a little bit recently. There's I had an idea years ago, something I called quality views, and the idea behind this was to go and have some way to make it easier for business people and developers to go and communicate about the state of the system. And in a nutshell, this is exactly what it is. It's just that you, for every major component in the system, you kind of give it a bit of a health grade. Like you can use colors, like, you know, dark brown versus like light yellow or something like that. And then when people are asking for features, you can go and say, oh, cool, we can do this. And it looks like that all resides, that feature can be implemented in this particular component, and that's got pretty healthy code. Yeah. But if it spans a couple of different components and one's like kind of poor, you can explain at least why it's difficult to go and actually add this feature now. And then, you know, that becomes like a bit of a prop for a conversation with business. And, you know, the one guy tried this out at Tesla, Colin Brecht, and he said it's really great because without talking about technical debt at all, you get into this situation where basically people are saying like, well, gee, can you do something about this area of code here? Because, you know, every time we ask for a feature, it's like, this is still dark red. You know, it's kind of like, can you work on this? Because we know that's holding us back. And I think that kind of thing of having transparency between the people that want stuff and then the team that's actually, you know, doing them is like an interesting thing. But the reason I mention that is that I've been playing around with the idea recently to sort of like say, let's take a system and sort of figure out what are like the 5 to 10 key responsibilities of it, and then use those as like the major areas for things, and say like, you know, you and I were working on like, say, a payroll system or something like that. We can figure out what the main areas of responsibility are. And then we can ask questions like, okay, here's a key responsibility. It's spread across 5 different locations. Do we like that or not, right? Yeah. Or like, here's one of those locations that this responsibility resides. are there other responsibilities there in that location? And if there are, then it's kind of like we at least have some kind of like imposed view of the system, which might help us, might give us guidance for how we actually continue it. How do we try to keep things within the boundaries when we're evolving this in a way? So I've been playing around with this as an idea, and it's been fun, you know. But
cool. It sounds interesting. I've got a few questions about that. So the first part. So the grading of the difficulty, the kind of subjective technical debt picture. Where does that come from? Is that based on people's opinion of the code, or is it some technical analysis of the code or something?
See, everybody wants to do the technical analysis and use the tools and stuff like that, and that can be great. The thing is, I get a little bit scared when people do that, because then you start having conversations of like, well, SonarQube told me this, so this is the truth, and you know, that kind of thing. I think at the end of the day, we are paid for our professional judgment about what the quality of the system happens to be, and we all have an intuitive sense about what's difficult to change and what's easy to change. And so we can use tooling to inform our opinion, but we have to own our opinion about that sort of thing. That's why I like to keep it subjective and say, let's use color gradations or like a scale of 1 to 10 or something.
So how do you keep that up to date?
Well, that's the interesting thing. I think that's it falls back into the one more thing problem, right? So yeah, I think that's something you can kind of, you know, I think if it's something that's the basis of a conversation with the business, then like every week or whenever it is that you're having conversations, you just refer back to it, and that's the way of dealing with that. But I think the thing I'm looking at now is like how to load this up even more. For instance, if we can see the system as basically like 5 to 10 responsibilities, you know, we might go and say, okay, let's have rules of engagement for these different responsibilities. Like whenever I'm dealing with the payments aspect, I know that I have 3 major refactorings that are kind of like in flight. So whatever changes you make should be aligned with those refactorings. You should either make progress on the refactoring or at least not do anything which is going to go and sort of like counter, you know, the direction we want to take the code over time. So I think I'm calling them responsibility indices. It's kind of like an index into the system based on responsibilities, and playing around with the idea with a couple of teams. And you know, I don't know. I think it's a viewpoint that people could use. The hard thing is how do you basically sort of, you know, make it something people want to keep up to date, you know, to go organize their work.
It's not quite the same thing, I don't think, but I worked on a team a few years ago, and we kind of kept an informal map of technical debt, the intent of which was, if you go into this bit of code, this is a problem that we could do with fixing. So you know, if you need to go and do a story in this piece of code, fix this problem while you're doing it, kind of thing. Which is kind of vaguely related, I think.
No, definitely is. And I think the other thing that is added to this is I keep coming back to this old quote from Kent Beck that I think it's probably something he might have said offhand at a conference someplace, and then somebody wrote it down. It's like, I think he said in the early days of object orientation, if you can't explain your system using 3 or 4 objects or 4 or 5 objects, you don't have a system. You don't have an architecture in a way, right? Yeah. And I think that kind of ties back to that 7 plus or minus 2 thing we were talking about with cognition. It's kind of like just for ergonomics or habitability, as you say, to be able to go and sort of say, at this scale, we can see the system as 5 to 10 things is so valuable that even if you don't have it, it's probably valuable to impose a vision of those things and gradually move the system in alignment with that.
That's making me think a little bit about Simon Brown's stuff as well, about the different levels of resolution of abstraction that you look at software architecture.
I wasn't aware of that. So Simon Brown?
Simon Brown.
Simon Brown. Okay. Got it.
So he's got a thing called the C4 architecture and a diagramming technique.
Right.
Look at it different resolutions.
I forgot about the resolution aspect of that. But
cool. So the second part that you were talking about, while you were describing it, it was making me think that sounds like identifying and mapping bounded context after the fact. Is that a reasonable kind of?
It is, except that the thing I'm playing around with is that these things might not be co-located in a way, right? depends upon the state of the system. That like if the system's gotten in a really crufty state, you might say, okay, well, here's payments, but payments are scattered across 5 places.
Yeah.
So it's kind of like
so the mapping to the solution might be poor, but so you're talking about the boundary context, but the mapping to the solution might be poor.
Right. So I think, and this is the weird, I think developers, I think people in general quite often have this problem of giving credence to a view of something that's not like really right in front of them in a way,
Yeah.
right? So it's like when you look at the physical architecture, it's like that's the truth, right? I can go here and here and here, and I know kind of where things are and stuff like that. But if you're kind of like if you have a responsibility view of the system, and then you say, well, okay, this is the responsibility views that we have these 5 or 10 things, and they're not really, it's not really aligned with the physical structure that we have right now, but we can move things more in alignment. I think to the degree that we can consider that responsibility true view of the system the ideal in a way, or the truth that we're striving for, we might be able to go and push the needle on some things a bit.
Again, the idea that that's triggering in my mind, and I think it's more than just both using the same word, but CRC thinking, just thinking about class responsibilities, collaborators. You can, and again, you can kind of do that at different resolutions of detail. You can think about the big picture things and the responsibilities of this subsystem of the system and this subsystem over here, and then you can zoom in and look at more detailed picture. And so
definitely. And I think I'm not thinking about the collaborator aspect as much, and I think most of it is, I feel like I've got to preface where I'm coming from with this, and it's like years and years of legacy code, right? So it's kind of like I keep thinking that anything which helps us kind of like stop the bleeding in a sense. It's kind of like we have responsibilities distributed in an odd way. At least can we move towards coalescing them? And it's like, sure, they have their collaborators, and that's a valid view of the system, but it's like some way of going and trying to get back on track with cohesion.
Yeah, absolutely. And again, this kind of gets into the one of the ideas that I think we've been alluding to throughout this conversation so far, but the idea of kind of cognitive load, the degree to which we can manage that complexity, whatever it might be, whether it's architectural or code level or legacy code, balls of mud or whatever else. How do we cope with being able to deal with that? Because just saying be smarter and hold more stuff in your head isn't good enough.
Yeah, no, totally. And I think it's really a rough thing. I every once in a while I just sort of marvel at how much the industry has changed since I first got in it, right? Which for me was like in the 90s, very, very early 90s. And it's back then I was like hired out of school to design a programming language and write a compiler, and I sat in a cubicle and did it myself. With like the guy who hired me basically as like a mentor to go and ask questions of periodically, right? And so that thing of like working in a completely solo environment, on a desktop, no virtualization, nothing, and being fully responsible for a problem. And then now everything is the teamwork and stuff like that. And then we're in a world where basically most software is online 24 hours a day. So we have to do ops support and all these other things. It's, I think that latter piece by itself, just essentially the thing of going and having to do pager duty and all these other things, it's like the amount of load that we put on ourselves, is quite tremendous. So I don't know, I go back to 2 things. I think microservices have helped quite a bit because you can at least, you have a bit of an enforced boundary, of something that you're paying attention to that's at a bit of a higher level than classes and stuff like that. But I also, think that we lose a bit too, because quite often people are doing pretty much ticket-based development. And it's like, it's going into a code I don't understand very well, make some changes, then go on to the next ticket. And I think to the degree that we're doing that sort of thing, where, we're basically sort of like shooting ourselves in the foot with regard to going and actually building any kind of like a larger consistent view of the system and maintaining it. So it's rough. I don't know what the answer is with that, but I know that really seems to be the background problem that we all should be addressing, I guess, as we think about how to make it better.
And I think that at the heart of the problem kind of then and now, kind of, the cause of legacy systems, but also the problem of building distributed microservice systems and all that, at its heart, at kind of computer science level, information science level, maybe even, is kind of the idea of coupling. It's nearly all to do with the degree to which parts of the system are related to one another, and parts of the organization are related to one another or not, and the problems that causes. If you have 500 small teams, but they now need to coordinate all of their work on every, to release things, it might as well be one big dysfunctional team as 500 small dysfunctional teams.
Fair enough.
So you need to think about the coupling in the organization and the software that we deliver to manage, to be able to manage that cognitive load, to be able to compartmentalize the systems in useful ways, so that we can keep an eye on that complexity and not let it explode out and compromise what we're doing. I see. I agree with you about microservices, although I'm a critic of them as well, because one of the patterns that I see so regularly is teams that claim to be doing microservice, but they still have to assemble everything together and test everything at the same version before they can release them. And you've just thrown all of the value out. So the idea of architectural decoupling using hexagonal architecture, ports and adapters, and version APIs between services, all of those kinds of techniques, just to allow you to maintain my freedom to change my service without needing to test it with yours before I release it, seems crucial to me to be able to do those things.
It definitely is. And it's a weird thing with this too. It's like when I'm going to go way abstract for a second, if you don't mind, but like we talk about like platforms these days, right? And it's kind of like I think that sometimes the base architectural things that we do, and even the process things that we do, become a platform for us, and they either facilitate ease of work and experimentation, or they don't, right? So it's kind of like, to the degree that if you're able to go and sort of like, if you have to test everything together, it's kind of like there's other trouble, right? And you're really you should be able to go and deploy things separately, and you should deploy things separately, so you can sort of see when things kind of fall out of whack. It's like simple things like that enable so much, but they really are like a development platform at the process level that allows you to do that stuff well. It's a nuance that gets missed. I totally agree.
Have you come across the Team Topologies book by Matt Skelton?
Oh yeah, totally. I love it.
Fantastic book, and I think that's one of those things that gives a step forward of starting to think about teams as a design tool to facilitate some of these behaviors.
No, totally. I think it's funny, like just the notion of a stream-aligned team and having a name for that sort of thing, and that's it's the thing I wanted to say is like, getting to be like a cranky old man now. It's kind of like the one thing I keep coming back to. It's fun. At a certain point in your life, you just have to go, run with it, right? But the thing I keep coming back to is kind of like, how could the world be different so that we could make software development easier, right? We're doing all the things we can to basically deal with a complicated world, but can we make the world different? It's a weird flip of things, just to go and understand things in a way. But the thing I keep coming down to is that it feels like scale is the enemy sometimes, right? The desire to go and scale systems up leads us to go and putting in all sorts of process architectural scaffolding to go and basically allow the work to go and happen. And we know in our hearts that the work is going to slow down because there's more coupling, and then there's more coordination costs across all the people and all the teams and stuff like that. And you feel like going to the product people and going and saying, well, that set of features you just asked for, that's another product. It's not the same product anymore. Can we just have another product which basically goes and stands on its own, and maybe it's a bit smaller, and then you'll get more rapidity of development, and it'll be a more niche thing. But this is all coming against like economies of scale and things like that. It's easier to take a big thing and make it bigger than to go and make more small things, at product level and stuff. And, so it's a weird thing. I wish that it were easier to have those conversations and sort of find the maybe 10% of cases where, making something completely new is a better tack than going and enhancing something that already exists. Because I think that's an underexplored path for many architectures, for many products. in a way.
Yeah, it is. It is complicated though. I think this is one of the things that I saw in one of your videos when I was kind of reminding myself of your work for talking to you about today. But one of the things that I think you said that I liked was that something that I believe profoundly. One of the reasons why I like doing software development is because it's hard. I like it because I like that it's difficult. I'm okay with that. I enjoy the challenge. I feel proud when I can come up with a nice solution to a problem that's genuinely difficult. And so I don't really mind that, but I think it is extremely difficult. And I think it's even difficult when we're doing simple systems sometimes. We're often just tiny steps away from some profoundly deep and hard to resolve problems. And if we make so it's a domain that's very easy to take missteps in, I think, software development. And I think one starting point is to recognize that and to just proceed more cautiously, more incrementally, with a little bit more defensive thinking in terms of design and implementation and so on. And some of the stuff we've been talking about is my version of that, compartmentalizing things and so on, so I can worry about it in smaller pieces and so on. But there are those different kinds of systems. So I dealt with a client who I won't name, but they build big, complicated scientific instruments. And one of the things that they were struggling for a long time, but it's a complicated problem. They are genuinely complex devices, these devices that they're building. And they're building the whole software stack, and they were struggling with that and keeping it, being able to make progress quickly enough. One of the ideas that they had, it wasn't my idea, but one of the ideas that they had at some point was to do exactly what you just said. And they said, why don't we just start writing some micro apps and just releasing those? And we've got this good simple idea. We'll just implement that as a standalone thing instead of it being part of this massive stack of suite of software. And we'll just do that, and it can get the data it needs out of the machine, crunch the numbers, and present this little tiny part of the answer to a question. And that kind of liberated them to try lots of other things, riff fast on ideas and try ideas. The counter to that is that we're also, industry wide, we're also building. We're building self-driving cars and space rockets that are going to go to Mars and all of those sorts of things. Those are software devices these days to a large extent, and you've got to solve problems on those scales as well. So one of the things, it seems to me, if we're going to think about engineering, is to think about engineering at different scales. It's not going to be exactly the same everywhere. There might be some principles that are shared at whatever scale you're doing it, and I think that there are, but it's not going to be the same. And one of the anti-patterns that I see is the other way around as well, which is tiny teams that are doing some relatively simple thing, adopting the technologies and the disciplines of Google or Amazon. Why? You're not Google. Nearly every team that I see these days starts with Kubernetes. Does every team need Kubernetes? Is that the best starting place for solving the problem that's in front of you, or is that just slowing you down? I don't know. So, but
no, I totally agree.
It is complex.
Definitely. And I think the skill makes a difference. All the context makes a difference for all these different things. And I think there's this other force as well, which is kind of like, what can people expect when you hire them, right? It's kind of like, I think some technologies become pervasive just because, it's kind of like, well, if I'm not using this technology, that's the thing I can't put on my resume. It's sad to, realize that some people think that way. But it's like, there's a lingua franca, I guess, that developers start to go and sort of like gravitate towards, and then basically companies realize that the hiring pool is there in a way as well, So I don't know. It's there's so many forces around this. It's really fascinating.
I think that's kind of, in some ways, it's one of the advantages. I started a little bit before you, but not very long before you. I started in my professional career in the 1980s. But I think that one of the advantages perhaps that we had was that the landscape was simpler. That there were fewer technical choices, there were fewer frameworks to pick up on. And so one, you either had to do more yourself, or you're going to be using frameworks that nearly everybody's familiar with anyway, because everybody uses it, or technologies. So, and that's different. So I'm a little bit wary about the explosion of third-party software that people rely on, and I'm not. I kind of agree to a significant to some degree that you don't want to buy, you don't want to build everything yourself. I don't want to write my own operating system or programming language from scratch, other than exercising curiosity anymore. But and things like the cloud, raising the level of abstraction on infrastructure management and operational consideration, all that is a good thing. But then again, I don't really want to be linking a zero pad extension to my language when I can write the function in 30 seconds.
It's it's really rough, and I guess it's there's so many things that really kind of fall down to economics, at least in my opinion, right? That's kind of like you are adding incremental value on top of an enormous pile of value, right?
Yeah.
And it's it's funny, as often as we talk about technical debt, I think that one thing that we need to appreciate as well is just that maybe the problem is that software is too valuable, right? We're scared to throw it away, because the cost of going and rebuilding things and stuff like that is just too large. So we just kind of end up accreting more and more and more and more stuff. And it does represent value, but it's also, I like people to be happy at work, and I like to basically have work environments which include the code itself, where people feel comfortable and able to to do the work and all these kind of things. But the economics kind of drives away from that sort of thing, and I think it's something we have to be kind of vigilant about, because we have to shore things up to basically keep that space for ourselves, it seems.
And there's a commonly a kind of naive reaction to that, in that we driven by that economics, we sometimes make the wrong choices as well as making the right choices. The overly simplistic view of what that means. That I often think about that when it comes to kind of the buy versus build argument. At LMAX, when we built our exchange, we actually use very little third-party software. Nearly everything that we wrote ourselves from scratch. And I'm not necessarily suggesting that that's what you must do, but it worked quite well for us. It put us in control, and that was one of the most efficient teams that I've worked on in solving complex problems.
It's an interesting thing, because I think with LMAX, to the degree that I understand, I mean, it's system software in a way, right? And it's kind of like it feels like it's a very strong vertical in a way, right? The LMAX architecture. Is that a fair characterization?
I think it is to a degree. I think it's certainly applying system software style thinking to solving the problem, and partly that's because of the problem domain had some fairly extravagant demands in terms of performance, and so that drove us to apply some of those. Really looking at trying to apply that kind of thinking to solving the problem.
Because it's
I think some of the techniques, I do believe that some of the techniques that we used there are more broadly applicable than just low latency finance systems.
I guess the thing I'm trying to, so I think people typically have like the systems versus application software split, but I think maybe another way of characterizing it is really kind of like systems where the complexity is physics bound versus people bound. In a way, it's kind of like, are you dealing with friction, speed, latency, all these other things, or basically a person who wants to basically change tax law and basically goes and now has to force like a different computation upon all the clients you have in your organization, or the person who wants a different color for the GUI and stuff like that. And it's kind of like in those two spaces, I think it can be, even though the problems can be hard in the systems realm or the physics bound realm, it's kind of like they are problems that kind of like can be a little bit more static than just, they're less capricious, I guess, than in the application space where like, well, we need this other feature for this particular thing just because we think there's a market there and you know. So I think there's a difference there, and I feel envious quite often of the physics bound realms in a way, just because they seem a little bit more solid. I don't know, you know. But, yeah.
Yeah, that may be true. I think
it's oversimplification.
I think it's a bit of an oversimplification, but I can certainly agree with you that there's parts of that are true, and certainly the stuff that we talked about, because so we were doing some of both of those things. So we were using the kind of the systems style programming to make some of doing the other things easier. I think that's the case. In reality, the core of our system were very rich domain models that modeled sometimes quite complicated human business processes and so on.
Okay, because all I know is that LMAX is reading the papers which describe the circular.
That's because that's mostly what we talked about, is the kind of lower level plumbing stuff. But I do concede that, you know, I think there's part of that truth. But I am a believer. You know, I am a believer that software, you know, computers and software are deterministic systems. You know, whatever they are doing it. So the inputs may change, but for the same set of inputs, you're always going to get the same set of outputs. The degree to which that's not true, I think, is more in our control than we think. The degree to which that's not true is when concurrency happens and we allow concurrency to happen. And so if you control concurrency appropriately, I think you can make what I've just said more true and get greater control, and you end up with more testable software, more deterministic software, more predictable software.
Before you mentioned concurrency, I started thinking, it's like, oh, we're kind of zooming back to the thing of objects, and, you know, good object orientation looks functional because you have control inputs and outputs. But it's like, the determinism story, that's side effects, you know, due to concurrency. And I guess a whole other raft of side effects that are possible with it as well. But, you know, that's the thing. We want to basically, so software has to be deterministic. Where we try to impose determinacy where we can to help us understand things.
One of the things that we did at LMAX was that we made the core of our system single-threaded. So each little bubble of domain logic in our system, every bubble of domain logic in our system was deterministic. So, you know, given the inputs, we get exactly the same input, and we even ended up rewriting things like hash maps so that the hashing order was predictable, so that we get the same hashing order for the same inputs and stuff like that, to up the determinism and improve the performance. So I think there are ideas like that you can apply that are more generally applicable and can make our systems stronger and better as a result, when we apply that kind of thinking. But it's still a bit bleeding edge, and it's not what most systems look like. I absolutely concede. But I think that my own view, having worked with some people who were genuinely, you know, Martin Thompson being one, genuinely world-class experts at concurrent systems, you know, their view is don't do concurrency unless you have to, always. And so my view, being less good than them, is that I'm always very keen to try and absolutely minimize the degree to which I'm relying on concurrency, and I'm not going to let that leak into any bit of code that I care about how it works. I'm going to work in ways that allow me to do it efficiently, but manage it cautiously.
That's one thing. The thing you just mentioned brought up something I think about every once in a while. It's like how often constraints are so helpful to us.
Yes.
And particularly that kind of thing. And so if you have a really hard problem, then if you're Martin Thompson, you know, or you might arrive at this thing that's like, okay, concurrency is the problem. If we just basically draw a hard line there, then you end up designing in different ways. And it's utterly fascinating how that happens. I had an
again, getting to that comes from that kind, in a way, it's going back to what we were talking about at the beginning, talking about test-driven development. So the way that we got to that problem was that we were trying stuff out. We came up with an architecture that was based on trying to we built something called a staged event-driven architecture, where you predict what thread you try and allocate a given instance, a given account or a user's, details or whatever to a single thread. And every time you process that one piece of information, you process it on the same thread. And we built this. They're supposed to be very fast, low contention, and therefore very fast, all this good stuff. We built one of those. We built an exchange based on those principles. We measured the performance, and it sucked. It was terrible. And we measured it. We started profiling it and looking at it all the way down. And we found out that we were spending more time figuring out where to do work than we were actually doing the work. So at which point we threw all of that away and said, we'll do all the work on a single thread. And, but we came to it through that kind of incremental step-by-step route design. That didn't spring fully formed from any genius's mind. It was hard work.
No, fair enough. And I think that's the interesting thing, is like it's kind of like you're forced into an unfamiliar situation. Like the profile tells you, okay, there's a problem, but there's still a problem. And then you're kind of like, okay, well, here's a different thing, let's try it out. And then it seems like there's a bit of courage in just going with it and going and saying, there might be a general principle here. And if we kind of like adopt this as the base, we'll be able to go and move even further in the direction we want to go. I think that's an interesting dynamic. But I think there are many people that either they don't connect that the solution that you've arrived at is something that can be expanded out into a bigger space, or maybe they don't have the will to do it or something. I think and so I think that's where it seems like a lot of innovation happens that way.
And that gets back to the stuff that I was saying before, is that I think ours is deeply a discipline of learning and exploration.
I always come back to curiosity, because it's just like if you really are kind of like, you want to figure things out. I mean, this is called the engineering room, but I have like an admission to make. I enjoy building things, but I'm also kind of like, I think temperamentally I'm way more of a scientist than an engineer. At the end of the day, if I understand something that I didn't understand this morning, it's like I call that day a success, regardless of on with things. But it's fun.
This is obviously, the title of this is obviously related vaguely to the title of my book, but I've got this thing for engineering at the moment. But like you, actually, that my interest in engineering starts from science, really. So I can understand. It's not perfectly true. It's not perfectly true, but I do tend to think of engineering, at least software engineering, and the practical, the kind of engineering that we're talking about, as being, the practical arm of scientific style rationalism.
Fair enough. But it is worth going and sort of trying to find the underlying stuff. That's a thing that I really kind of feel. I know it for myself, it's kind of helped quite a bit. It's funny that the whole constraint thing, I had this early experience that was like an imposed constraint on me that led to an insight I probably wouldn't have had otherwise. And I can, I guess, repeat it very quickly, but it was like working at a biomedical company, we had to go and write software that would be embedded in instruments out in the field, and you couldn't update it anytime soon. But we wanted to go and have these several chunks of code that had to be completely independent of each other, but use a common library. And I was tasked with writing the library that would be used for this. And so my boss at the time, the guy who hired me, basically said, it's just like, don't have any global static, mutable data. And it's like, okay. So looked for all the different opportunities for that sort of thing and made sure that everything that was global was constant and immutable. And it was really an interesting thing to go notice that I had to pass things, down through the system, that things that could have been global were no longer global. They had to basically just be passed down a tree of objects in order to go do things. And I realized that was changing the way that I was designing. And I thought, we're looking at this as being a problem. It's like, oh, damn, I'm passing things. But then it forced you to really think about where things are being used. And you actually end up with a different architecture, because it's a pain to go and pass something. So you only pass in the areas that you need. And then you get some real separation of concerns, because this area over here uses, this was even down to the level of memory. So basically we were passing a memory object to every place that needed to allocate memory, and discovered there's only a few places, versus what's typical in systems design, where you have access to new every place you go. If you choose to go and actually allow your architecture to reflect these things, you get better separation of concerns, at least different separation of concerns. And that was really like an interesting insight, for me at least, to see that, the typical thing that people say against globals is kind of like, okay, it's going to cause trouble. It's going to be, you'll have side effects across the system. But it's kind of like you actually erase design information when you use global sometimes, right?
Yeah.
Yeah, fun stuff to kind of realize this just by having constraint, and
the data version of GoTo.
Yeah, fair enough. I was like, it's like wormholes in space-time or something.
yeah, absolutely. but that again, that feels like it kind of closes the loop on the conversation into the idea of constraints. When we started off talking about test-driven development, that's one of the things that we're doing. Really, we're setting up a series of constraints on our code that we plan to abide to, and there's kind of some meta level constraints that what makes good tests. And then there's the specific constraints that we embody in our tests. I have a penchant for behavior-driven development thinking and terminology somewhat, because I think it helps a little bit with some of this. But the idea of these things being genuinely specifications that constrain the solutions that we're going to do to fulfill some desirable behavioral outcome that we identify, even at the fine-grained level, I think is quite a nice way of thinking about these things.
Yeah, definitely. And one little story I like to tell sometimes, which I think is really kind of helpful for people, it's like they're often like, I want to write tests for this existing system. And it's kind of like, then you discover it's like, well, to instantiate this object, and you instantiate another object passes like an argument. And you need to have this other global object available to you. And you end up going through and doing like 15, 20 different things to set things up just to instantiate the object you care about, right?
Yeah.
And it's something we've all experienced. And I sort of, I tell the story of like, imagine you go to the rainforest someplace in South America and you see this brilliant blue frog, and you want to go and take it back home with you to England or to North America here. And you take it, you have this little terrarium, and it dies 3 days later. Why did that happen? And it's like, well, basically that frog evolved in an environment where it had a certain temperature, humidity, daylight hours, particular food sources. And you didn't know about those dependencies when you moved the frog, right?
Yeah.
Much the same way, I think when we add code to existing systems, we're using what's there available to us in place.
Yeah.
And we never think about those things because they're so readily available. But in TDD, it's like if you build something new inside its own test harness, you're confronting every single thing that you depend upon is something you have to supply at that point.
Yes.
And the work of doing that leads you to basically think about minimizing dependency. It makes you aware of what dependencies you're introducing in the new thing that you're writing. And I think that thing of kind of like building things in a hermetically sealed container, in a way, in TDD is like it's a great frame for getting people to understand that particular thing. So I love to repeat that story. Thanks for indulging me.
No. It's a great story. I really like the analogy. I might steal that one from you.
Feel free. Spread it. Yeah.
I think we're coming to the end of our time. Are there any things that you'd like to add to kind of wrap up our conversation, or to throw in some grenades that we have that we should tackle?
Yeah, no particular grenades. I think one thing I've been working on a lot recently is a little bit beyond software in a way, which is really trying to go and sort of articulate different structuring principles that happen in systems. And I'm always fascinated by when you discover something that works in software, but it works in a social system also. Yeah. And things along those lines. And so, it's kind of funny leading up to this talk. It's like I work in software development. I've been dealing with those things. My head's been in this other space of understanding the dynamics of, how technical systems, social systems, and, and all these other physical systems tend to kind of, what are ways of seeing these things that help us when we're trying to go and change them. Yeah. So I hope to write more about that later, and, it'll be, just follow me on Twitter, anybody who wants to, and I'll talk about that sort of thing periodically if you're interested in it. So we'll put some links. If you've not come across Michael's work before, I hope that hearing him talk today has given you a flavor of what a thoughtful person he is about some of these things, and I think a deep thinker about some of these ideas. Michael, it's been a pleasure as ever to talk to you today. Thank you so much for agreeing to do this. It's been a lot of fun. Thank you so much. Thanks for having me. It's been fun. Absolutely fun. Great. If you've enjoyed the episode today, hit subscribe, hit like. We'll put details, links to some of the information in the description below that we've alluded to during our conversation, and Michael's Twitter handle, at least, so you can follow him on Twitter. Thanks, everyone. Thanks, Michael. Bye.